This is the Mars rover Perseverance, the most advanced robot to land on another planet. In this video, we'll take a look at how it was built, the Atlas V launch, the journey to Mars, and the scientific instruments that allow it to study the surface. On February 18, 2021, the Perseverance rover successfully touched down on Mars. It costs a total of $2.5 billion. It has many scientific instruments to help study Mars, search for signs of life, and prepare the way for future human explorers. Perseverance is, of course, not the first rover to visit Mars. Sojourner was in 1997, a very small rover, and here's a person for size comparison. Spirit and Opportunity in 2004, these were identical rovers sent just a few weeks apart from each other. Curiosity landed in 2012, and then Perseverance in 2021. Same size as Curiosity, but much more advanced technology. This is not a complete list. This just shows the most recent rover sent by NASA in the United States. For most of this video, I'll be focusing on Perseverance. NASA designs and builds the rovers in Pasadena, California at the Jet Propulsion Laboratory, or JPL for short. This took about 8 years of designing, building, and testing to get Perseverance ready to go. It was built in a clean room that's free from dust or other contaminants. It's designed to work on another planet, different atmosphere, different gravity, and most of all, no repair station. It has to be engineered so well that it can last for years on its own. On top of that, it has to be light and compact so it can fit inside of the launch vehicle. Once it was ready to go, the rover was carefully packaged up and then flown across the United States to Kennedy Space Center in Florida. This is where the launch happened, the same place that NASA has been launching rockets since the 1960s. Perseverance was installed along with several other components that went along for the journey to Mars. We'll talk about each one of these pieces later in the video. This was all put inside of the payload fairing, then taken to the rocket and then lifted up to the very top. This rocket is called an Atlas V. It's made by a company called the United Launch Alliance, or ULA for short. Let me point out that the rover was actually upside down for the launch. The best time to launch to Mars is about every 26 months. If we show this with the correct scale, you can barely even see the sun. For this animation, I'm going to show this out of scale so we can see this a little better. For the Earth to get around the sun, it takes exactly 1 year, right? No surprises there. Mars, on the other hand, takes almost 2 years to get around the sun. The best time to launch is right before Earth and Mars are lined up. This is called a launch window, and it happens about made up of a few pieces. Here's the rover, all folded up inside, the descent stage, this has 8 rocket engines on it, the heat shield, which slows us down through the atmosphere and protects the rover, the back shell, which protects the rover as it descends to the surface of Mars, and this is the cruise stage. It provides power, fuel tanks, and thrusters, and also keeps in communication with Earth. This whole assembly stays together during the 7-month journey to Mars. We'll need to adjust our path along the way. We do this with the thrusters on the side of the cruise stage. This is called a trajectory correction maneuver, or TCM, and there are several of them on the way to Mars. Landing on the surface of Mars is nothing short of intense. They call this EDL, or Entry, Descent, and Landing, often nicknamed the 7 minutes of terror. This is because if anything goes wrong, then we'll likely fail to get the rover safely to the surface. At the time of landing, it will take about 11 minutes for any signals to reach Earth. This is, of course, traveling at the speed of light, the fastest that we know how to communicate. It doesn't seem very fast, does it? 11 minutes is a long time. To put this in perspective, from Earth to the Moon, light takes just over 1 second to get there. When the Apollo astronauts were landing on the moon, NASA could communicate with them almost in real time. It would take about 2.5 seconds to receive a reply. On Mars, this is completely different. If something goes wrong during the landing, mission control won't hear about it for 11 minutes, and any reply would take another 11 minutes to get all the way back. By this point, it will already be over, either a safe landing or a crash. This means the computers, electronics, and the software must be smart enough to do everything on their own. EDL, entry, descent, and landing. Let's follow this through step by step. About 10 minutes before entering the atmosphere, the cruise stage is detached because it's no longer needed. Small thrusters on the back shell will now be used to steer the spacecraft. Next comes atmospheric entry. The heat shield will protect the rover during this time. Once we get about 11 kilometers above the ground, then the parachute can deploy. It uses a technology called range trigger, which finds out how close we are from the landing site and then deploys the parachute at just the right moment. Next step is heat shield separation. For the first time, the Perseverance rover can now see the Martian surface down below. Now we use terrain relative navigation. The rover will be taking pictures of the ground beneath it and comparing these to maps of Mars. This will be used to safely steer the rover towards the intended landing site. Next comes back shell separation. All that's left is the descent stage and the rover. The rockets on the descent stage fire up to slow us down as we get closer to the surface. Then the rover separates but still attached by some cables. They call this the sky crane maneuver. The final part everyone is waiting for, touchdown. The cables are cut and the descent stage flies off into the distance for a crash landing far away from the rover. Now it's time to check out the rover's systems, deploy the mast, and then the robotic arm in the very front. The main purpose of the Perseverance rover is to look for signs of life. It landed in Jezero crater, which, billions of years ago, used to be filled with water. Where there is water, there is usually life, or at least signs that life existed in the past. Perseverance rover has an array of advanced scientific instruments to study the surface of Mars. If you remember from earlier, the rover is enormous. It's about the size of a car. The main body of the rover they call the Webb, Warm Electronics Box. Then you've got 6 wheels, 3 on each side, that are made of aluminum. The front and back wheels can turn, allowing the rover to spin a full 360 degrees. The suspension system allows the rover to travel over rough terrain. You never know what kind of obstacles you're going to come across on Mars. But to be more realistic, the rover would be going about this fast. It has a top speed of 0.1 kilometers per hour. The slow speed is mainly for the safety and stability of the rover. This is the remote sensing mast. This is the place where you'll find some of the cameras and sensors of the rover. It's just a little taller than the height of a human. The idea is to give us a similar view of what a person would see if they were here on Mars. This big circle up on top is called the supercam. It's basically a laser that can identify chemicals in rocks from as much as 7 meters away. This is the Mast Cam Z. These are the main cameras on the rover that can even take high-definition video. Navigation cameras are used to help the rover safely drive on the surface of Mars. Right below is the Mars Environmental Dynamics Analyzer, or MEDA. This is studying the weather and atmosphere on Mars. The rover has 2 microphones, one on the mast, and then another on the side of the rover. Keeping up with the most important topics nowadays can be time-consuming. How do you stay informed without just aimlessly browsing social media sites? It can be a huge time waster.